All right, so the recording is in progress. So our objectives today, we're going to go through section 3.4 and 3.5. I believe they're squished together into one assignment. So it's 3.4 and 3.5 is one homework, and then chapter 4 is the other one. So I believe that that's how it's set up because they all fit together. So we're going to talk about z-scores, and we're going to talk about quartiles. We're going to do a whole bunch of stuff. So z-scores has nothing to do with median. Z-scores is strictly with standard deviation and mean. And then we're going to jump, and everything else we do is going to have to do with median. We're going to learn something about interquartile range. We'll look at quartiles. We're going to talk about how to find outliers using the median. And then we're going to learn about 5-number summaries and box plots. And I'll show you how to draw a box plot. And I have it under pretty good authority that for your first test, you will need to draw a box plot. So pay attention, take good notes. And since you are allowed notes on your test, it's a good idea to do whatever you need to do in order to make your notes good enough so you can get all the points for that. After that, we do all of that, I'm going to walk you through lab 2. Yes, there are 2 labs this week, and that may seem pretty intimidating, but lab 2 should only take about 5 minutes, maybe 10 at the max. And part of the reason for that is because you can use the data from lab 1, your continuous data. If your data was actually continuous, there were a couple of people, if their continuous data wasn't continuous. If that's the case, you're going to need to get new data, but most of you had good continuous data. So just use the same stuff. Just copy it, paste it into this lab. So you won't have to do any searching to find new data, and everything you could do, Excel is going to do all of the magic for you. So I'm going to walk you through that, and it should be a pretty quick one. So let's get going. I guess I need my iPad. Okay, so what a z-score is, it tells you how far the data value that you have is from the mean in terms of standard deviations. So what I would be able to tell you that a value is 1.5 standard deviations away from the mean. This is really helpful because of the empirical rule. So remember, on our empirical rule, we have that 68% of our data is within 1 standard deviation of the mean. And then we have 95% of our data is within 2 standard deviations of the mean. So being able to calculate a z-score is really going to help us to determine where on this normal curve a data value lies. And we'll be able to tell if it's an outlier. We'll be able to tell if it is super close to the mean. And it's going to make it really easy to compare it to other people's works or other values. And we're going to do examples of that. So when we're working with population, the z-score looks like this, and this should not be this. This should be sigma. I need to fix that. I need to make a note to myself to fix that. So when you are calculating the z-score with a population, your z-score is calculated within the numerator. It is x minus the mean divided by the standard deviation. They're both the same, they just have different symbols. So you would take your value, whatever data value you're looking at, subtract the mean from that data value, and then divide it by your standard deviation. Really important, if you're putting the entire thing in the calculator at once, you need to put parentheses around the numerator. Otherwise, you're going to end up with a value that is not what you're hoping for. So be really careful. Make sure that if you put the entire thing in the calculator at once, you put those parentheses around the numerator. Same thing, sample. It's my data value minus the mean divided by the standard deviation. Same thing. You put it in your calculator. Make sure you put parentheses around your numerator. Give you a second to write those down, which you probably already did because I was talking a lot. It happens. All right, we're going to do some examples, and hopefully this will help. Maybe if I can get to the next screen. I'm having this trouble all day with my, oh, and there's no units. The z-score is unitless. So you wouldn't say 2.5 liters or 2.5 meters or anything like that. It is just your Z-score is 1.6 or whatever. There are no units. So biggest thing that we use Z-scores for is when we're comparing two things that have different populations and we're trying to compare them, or if they have different mean and standard deviation. If we convert it to Z-score, it's kind of like standardizing it or converting it all to the same units. So for example, right here, the mean height of a male is that's 20 years old or older is 69.1 inches tall, with a standard deviation of 2.8 inches. A female's height, the average height is 63.7 inches with a standard deviation of 2.7 inches. I find that hard to believe. I don't think that, I can't imagine that the average height of a woman is 5'3.7, but maybe it is. Anyway, so I can't just automatically say, oh yeah, well, so Kevin Garnett is 83 inches tall and Candace Parker 76 inches tall. Obviously, Kevin Garnett is taller, but who's relatively taller? Who is taller compared to others? Like, how is Kevin Garnett taller compared to other men than Candace Parker is compared to other women? That's what we're trying to figure out. We're going to convert them to a standard way of expressing it, convert it to Z-scores, and then we can compare those Z-scores. So that's what we're going to do. So we're going to start with the Z-score for Kevin Garnett. And we're going to take the data value, which is 83, subtract the mean, which is 69.1, and then divide it by the standard deviation, which is 2.8. So in my calculator, I'm going to put parentheses around the numerator, and then I'm going to do all of that math. So I'm going to do parenthesis 83 minus 69.1, close the parentheses, divided by 2.8. So his Z-score, Kevin Garnett's Z-score, 4.96. Wow, that's crazy. So his height is 4.96 standard deviations above the mean. So remember, any data value that is more than 2 standard deviations above the mean or away from the mean is an outlier. So his is like way out there. He is way off in that 99 or past the 99.7, the 0.15 at the top. So let's take a look at Candace Parker. So she is 76. So I'm going to take 76 inches minus 63.7 and divide it by the standard deviation, which is 2.7. Once again, remember the parentheses. I'm going to put this in my calculator. Still a pretty big Z-score, but her Z-score is 4.56. So she is still an outlier, but relatively, Kevin Garnett is still taller. He is still relatively taller because his height is more standard deviations away from the mean than Candace Parker's height. Questions? I'm going to do another one. Questions? Right.
I have a question. So yesterday I was doing the homework and I figured out like how many deviations away from the mean, but then when I would try to calculate the percentages,
What percentages?
they
What are
were
you
off.
talking about? What
Like
do you mean?
you know how like when you know the percentages, this was the problems yesterday. So when you're doing it's like 38% or 34% in the middle, and then they have the
Oh,
13.5.
so like with the empirical rule, you mean?
Yes.
Okay.
Sorry, I'm off subject a little bit. But when I would say they're three standard deviations away.
Uh-huh.
Sorry. It would be wrong. So how do you know, do you count everything in between?
Yes. So I'm going to go to the other screen real quick here. So if I had, here's my beautiful, so this is the mean. So this is 34%, and this is 34%. And then I have 13.5%, I think that's 13.5%. 95 minus 68. I don't trust myself right now. Okay. And then we have 2.35 point one, is this 0.15? Yeah, and 0.15, wait, 2.35 and 0.15. So if I'm wondering, if you're looking at, like, for example, what percent of the people would be greater than, like greater than 2 standard deviations? So I want to know, what percent are greater than this green line? I would have to add this one and this one together.
Okay. Okay, so that would be like the third and the fourth. Is that the third and the fourth?
Well, this is the third and then everything after the third.
Everything after. Got it. Okay, thank you.
You're welcome. Anyone else before I close this? Have a question about the empirical rule? Okay. Pop off of there.
I'll ask a question about the Z-score.
Okay.
Okay, so if let's say, for example, Candace's Z-score was 3.00. I don't know if that's
Okay,
possible.
we're gonna pretend.
Just say that is.
Yeah. So
So
let's
that-
pretend she has 3.00. Okay.
So that's in the bell.
Well, I mean, it's still an outlier.
Still an outlier, but okay.
Anything,
But still within
anything,
3.
yeah.
Okay.
But anything more than 2 standard deviations from the mean is an outlier. So I'm gonna go back to this other screen.
Okay.
So this is my lovely perfect. Let's pretend this is a perfect bell curve. Good thing we don't deal with absolutes. So this is my 34. I'm not putting percents. I'm trying to do this quickly. Just imagine there's percents there. So you draw this enough, you just kind of. Okay. So even though we have our 3, this is our 3 away, this is -3 standard deviations, this is +3. Even though they're still on our curve, and this is still 99, this is still 99.7% of our data is in there. The outliers are anything more than 2 standard deviations away. So anything out here and out here, whoops, that's too far. So anything out here, I'm gonna do a different color because I messed up. So anything that I'm highlighting blue right now is an outlier. The usual values, the values that are not outliers, are these values in here. These are not outliers. So anything more than 2 standard deviations away from the mean is an outlier.
Got it.
And basically anything with less than 5% chance of happening is an outlier. So that anything outside of the 95%. So all of this stuff, all of this stuff is good. Anything outside of that is an outlier. So if I have a Z-score of 2, that's not an outlier, but if I have a Z-score of 2.01, that is an outlier.
Mhm.
So it has to be more than 2 standard deviations from the mean.
Okay. Good visual. Thank you.
You're welcome. My perfect drawings, pretending I have these beautiful perfect drawings, and then I just lost, doggone it, I'm having issues. All right. Can I move on now? We good? Okay. So let's do another example. So we're going to determine whether Los Angeles Angels or the Colorado Rockies had a relatively better run producing season. So the Angels scored 773 runs and they play in the American League. The mean number of runs scored is 677.4 and the standard deviation is 51.7. The Rockies scored 755 runs in the National League. The mean in the National League is 640 and the standard deviation is 55.9. So we're trying to see which one had a relatively better season. So go ahead and see if you can calculate those Z-scores. Just take a moment. I'm going to do it quietly behind you. Okay, so if you get stuck, you can look up. once the answers are both up there. Once you're done, go ahead and look up, see how you did. Right, so you can see the Angels, their Z-score was 1.85. The Rockies had a Z-score of 2.06. So even though they scored fewer runs, relatively, they had a better season. They had their number of runs, they're an outlier. So they're greater than 2 standard deviations away from the mean. So their runs this year, they were an outlier. So they did really great. I mean, not that the Angels had a bad season. 1.85 is still really close to that 2 standard deviations, but the Rockies did amazing. So relatively, they did better. Does this make sense? Questions? All right. So I believe that this next quiz has a question about where do you find outliers in the empirical rule? Or I believe it has something like that. Where does it hide in a normal curve? Where do you find it according to the empirical rule? I'm not sure how they word it. So make sure that you state that they're 2 standard deviations away. So outliers are anything with a Z-score greater than 2, or anything that is 2 standard deviations away from the mean. Even though it still lands on the curve at 3, it's an outlier at 2. All right, any other questions before we move on to stuff with medians? All right, going once. All right, moving on. All right, so now we're going to talk about median. So we haven't touched on median a whole lot because we've been dealing with standard deviation and mean. And it is really important to remember that we only use standard deviation when we are dealing with mean. If mean is your center, standard deviation talks about how spread out your data is. So when we are using median, though, we use something called quartiles. So with quartiles, it divides your data into 4 pieces. So remember, median cut your data in half. Quartiles cut it into fourths. So we're going to do it with a couple different data sets, and hopefully you'll get it and you'll grab onto it and you'll do really great with it. So the first quartile is the bottom 25% of your data. And this is a whole lot of words just to say that the first quartile is the bottom 25%. It divides that, like that spot, there's 25% of your data is below that first quartile. We're going to do math with it and you'll be able to visualize it in a second. The second quartile is the median. We almost never say second quartile. We usually just say median. Median cuts it in half. We've already done that. We are good. Third quartile. Third quartile is at the 75% mark, and it separates the bottom 75% from the top 25%. So you'll have 25% above the third quartile. Then you have 25% in between the median and the third quartile, 25% between Q1 and the median, and then 25% below Q1. You're going to see it visualized pretty good here. There you go. This is probably what you would want to put in your notes. This diagram right here. It says it so much better than all those words. So if anything, that diagram is what you want. I'll give you a moment to draw the pretty picture. Anyone need another moment?
I do.
Okay, no problem.
I'm good, thank you.
You're welcome. All right, and move on. Move on. Okay, so let's find some quartiles. first thing we want to do is, just like we did with median, you want to arrange your data from smallest to largest, just like we did with the median. Then the first thing you're going to do is you're going to find that median. Well, I guess it's the second thing you do. Find the median. That's your second quartile. We pretty much never call it Q2. I only ever see it written as Q2 in pretty much these slides, but it's just always the median. Next, you're going to basically find the median of the lower half. That'll be Q1. And then you find the median of the top half, and that's Q3. Once we actually do it, you're going to be like, oh yeah, that's easy, no problem. So it's in words, it's a lot more complicated. It looks a lot more complicated than it is. It's pretty basic. You'll be okay. So let's take a look. So I have some data here. This data is a group of Brigham Young University, Idaho students collected data on the speed of vehicles traveling through a construction zone on a state highway. The speed limit was 25. And so we recorded a speed of 14 randomly selected vehicles. This is a sample. Doesn't really matter with median, but I'm just letting you know it's a sample. I've already put them in ascending order. Because I don't like dealing with trying to put them in order, I already did that. So we have our smallest value is 20 and our upper value is 40. So we're first going to find the median. So remember, the median is smack dab in the middle, and these are 14 vehicles. So it's going to be in between 7 and 8. So 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be right here. And if you couldn't tell by looking that it's 33.5, you would just do 33 plus 34 divided by 2, and that would give you the 33.5. So this is the median. It's at 33.5. Did I count those right? 1, 2, 3, 4, 5, 6, 7. And why didn't y'all tell me I put that in the wrong spot? Somebody's got to correct my math. It should be right here. I'm sorry if I messed it up. That's why I do math in an erasable thing. It's 32.5. We would do 32 plus 33 divided by 2. Sorry about that. I was like, that doesn't look like the middle. Okay. So now I have 7 values below my median, and I have 7 values above my median. So I need to find the median of the lower half. So the median of the lower half is going to be right here. I really did get the middle this time. The median of my lower half is right there. This is Q1. This is quartile 1. Now we find the median of the top half. 1, 2, 3, 4. This is the middle number of the top half. So this is Q3. So all it means by interpret is 25% of my data is right here. 25% of my data is right here. 25% is right here. And 25% is right there. That's all that means with the interpret. And that's it. You found your quartiles. That is all we do. Questions?
I have a question. It's a little off topic, but you said that we get to use our notes for our test.
Yes.
So I usually print the whole slide and then I take notes on the slide.
Yeah.
Is that going to be allowed?
That's fine. Yeah, I absolutely,
Okay.
I mean, I encourage taking your notes directly on the slide. It kind of doesn't make sense to just write it all out if you can't have the ability to print it. Because this would be a lot of
Thank you.
writing. So yeah, absolutely use the slides. If you're writing on them and taking notes on them, yeah, go for it. That's what I would do. Okay, anyone else, any other questions on or off topic? All right, move it on. Okay, the interpretation, I just told you this. The 25% of our speeds are less than or equal to the first quartile. 50% of our speeds are less than or equal to the middle, the median, and 75% of our speeds are less than or equal to the third quartile. That's it. This is not fancy. I'm not going to actually ask you to interpret them because I just don't feel the need to. So this particular thing you will not have to interpret, but you are going to have to use it for other things. Okay. Move it on. So this is some other data that we have. This is Highway Loss Data Institute routinely collects data on collision coverage claims. So basically somebody submits a collision report to their insurance. The insurance company pays for repair. And so this is different values right here. This is a random sample of 18 claims from the Highway Loss Data Institute. So we're going to find, I would like you to find the first, second, and third quartiles. So find the median, then find the first and the third quartiles. I already put them in ascending order because who has time for putting them in order? And so go ahead and there's 18 of them. So go ahead and see if you can find your quartiles, and I will quietly find them behind you. I'll let you do it first. Let you get started. Remember, there's 18. I know it was pretty fast, but I did kind of cheat because I have it written down. All right. Did we all get there? Feeling okay? I'm going to quickly show you the calculator. You don't have to put them in because we did this last class. We put the things into the L1. I mean, unless you need more practice with that, and we ran one variable statistics. Hopefully you've been playing with it and you're feeling better. But I'm going to show you that one variable statistics screen and how it can help you. I'm on the wrong spot. Okay, here's my calculator. I put the highway loss data into my L1 list. So here's all the highway loss data right here. And when I first put them in, I made a typo. And so I had to go through it and find the error. That is most common error is typo in your list. So always look it over again. So I have my highway loss data there. So I go to stat, calc, and we want the first option. And I want my list to say L1. We leave the frequency list alone. All right. So I don't really care about, uh-oh. I'm thinking I must have something wrong. Maybe I didn't. Let's see. 18 Q2, my median is 1805. No, they look good. They look right. Something wonky happened with something else. Okay, so my Q1 is 735. So this will give you your quartiles. So if you just put your data into your calculator, you can, it gives you the minimum, it gives you Q1, gives you the median, gives you Q3, and gives you the max. You're going to need all 5 of these numbers for something called a 5-number summary pretty soon. But you can get the Q1 and the Q3, so you don't even have to put them in ascending order. You can just put it in your calculator, and your calculator will do all the work for you. This is the one variable statistics that we talked about on Thursday, your fancy calculator function. So it's just right down there at the bottom, your Q1, median, and Q3. Uh-oh, what the heck? There we go. I don't know what happened. I think my calculator did my, oh, I lost my, my browser. Wonder why it crashed. I don't think I need it. I don't know what happened. All right. I'm just going to go back to this screen. We're going to leave the calculator alone, but those are right there. Move on. So we're going to talk about interquartile range. So interquartile range is median's version of standard deviation. And so it basically just tells you how spread out your data is. So if it's smaller, then your data is probably closer to, the values are closer together. If it's bigger, they're probably spread more apart. But it just tells you, it's basically the range of the middle 50% of your observations. So the interquartile range is just Q3 minus Q1, and it gives you that middle 50%. So for example, I'll give you a second if you're writing it down. I tend to get excited about the math and just move fast. All right. So this is the speed data. So here's Q1. We found out Q1 was 28 and Q3 was 38. And so you just take Q3, subtract Q1, and my interquartile range is just 10. We're going to use this interquartile range in a little bit to find outliers. That is its main purpose, is we use it to find outliers, and I'll show y'all how to do that. So you can find, and I know it's kind of confusing, but when we find outliers based on the mean and standard deviation, I remember the 2 standard deviation rule, we find mean and outliers that way. And sometimes we find outliers using the interquartile range. Sometimes there will be an outlier for one and not for the other. And it just really has to do with the spread of your data and the skew and whatnot. So just go with whichever measure of center you're using to analyze your data, go with that one for outliers. I think your homework is going to ask you to find it both ways, sometimes in the same question. And just don't freak out if one way there's an outlier and the other way there's not an outlier. So don't freak out. All right, moving on. Okay. So we added a 15th car. 15th car went through the construction zone, and it went through really fast. It went through 100 miles per hour. So I want to talk about how this impacts the mean, median, and standard deviation in interquartile range. And this kind of tells you when there's outliers, why we like to use the median when our data is skewed. So take a look. Without the 15th car, our mean was 32.1. Once that 100-mile-an-hour car went through, our mean is now 36.7. So it went up by about 4.5 miles per hour. Take a look at the median with and without the 15th car. Our median without the 15th car was 32.5. Once that last car was added in, it's now at 33 miles per hour. So it barely moved. So our standard deviation was 6.2 without the 15th car. It went all the way up to 18.5 with that 15th car. So it had a huge change. Now the IQR was 10 with that or without that car, and it only went to 11 with that car. So that barely changed. So when our data doesn't have outliers, mean and median or mean and standard deviation are great. But as soon as you start throwing outliers into the mix, sometimes the median is the way to go. So this is kind of a when to use each. So if you are making that decision instead of somebody else making it, if you have a nice symmetric distribution, go with mean and standard deviation. If you don't, if it's really skewed left or right, then use median and interquartile range instead. Most of the time it's going to be you're going to be told what to do. But for example, on your final project, you're probably going to have to think about that on your own. Or if somebody just asks you, which one's better? Then this kind of gives you an idea of which one's better. Questions here? Right, moving on. Here's how we find outliers when we're using quartiles in the IQR. So you need your first and third quartiles and find the IQR. So you find that IQR. Then we're going to find something called fences. Fences are the upper and lower bounds of our normal data. These fences help us to determine our outliers. So our lower fence, you take Q1 and you subtract 1.5 times the IQR. So after you find that interquartile range, you take whatever value is at Q1 and you subtract 1.5 times the IQR. The upper fence is quartile 3 plus 1.5 times the IQR. So you add 1.5 times whatever that interquartile range is to quartile 3. Any value higher than the upper fence or lower than the lower fence is going to be an outlier. As I just said. I'm going to do a couple examples. Questions?
Can you repeat what you just said? Everything upper or lower than the fence is a what?
Everything higher than the upper fence or lower than the lower fence is going to be an outlier.
Thanks.
We're going to do some examples and we'll have some nice visuals for you. All right, can I move on? All right. So let's check the speed data for outliers. We're not going to use that 100-mile-per-hour car. We're only using the originals. So we had our first and third quartile, and we calculated our interquartile range. So I'm going to take, for the lower fence, it's 28, which is my Q1, minus 1.5 times IQR. This right here is the IQR. And I have 13 miles per hour. Then I'm going to take my Q3, this right here is Q3, and I add 1.5 times the IQR, and I get 53. So any number lower than 13 or higher than 53 would be an outlier. There are no values that are higher than 53 or lower than 13. So our speed data had no outliers. Now, if we would have included that 100-mile-per-hour car, darn right, that would have been an outlier because it'd be higher than 53. But since all of our values are in between these two values, we don't have any outliers. Questions? Okay. I'll give you a moment. I always get excited for the box plot part, which is coming up. Love the box plot part. Okay. So we're going to use the collision loss data to determine if there are any outliers. So as a reminder, our Q1 was 735. The Q3 was 4668. So first thing you need to do is you need to find your IQR. So the IQR is Q3 minus Q1. So 4668 minus 735, which is 3933. So this right here is my IQR. So let's find our fences. So I need to do Q1. So I'm doing Q1 minus 1.5 IQR. So that would be 735 minus 1.5 times 3933. It is okay. This number will not make any sense. I'm going to math it out real quick because I have it on my paper, but it doesn't look like it's right. It is. So this number it doesn't really make sense because 5164 at 50 cents. It doesn't really make sense because you're not going to the insurance company isn't gonna make $5,164.50, but it's okay. Obviously, none of our values are lower than that lower fence, but that's fine. So our lower fence is negative 5,164.5. Let's do our upper fence. So this is lower. So I'm going to do Q3 plus 1.5 IQR for my upper fence. So I'm going to take this 4668 plus 1.5 times, whoa, yep, 3933. And that value is $10,567.50. That is a really high number, but I have a data value that is higher than that. So we do have an outlier. That's a Q, that is not an O. I have an outlier. I see I did it again. Sheesh. Outlier. Because I have a data value that is higher than this upper fence, it is an outlier. So that outlier is 21,147. That is the highest number in our collision data. So if I'm gonna hopefully not hurt your head by doing this, by bouncing back really fast. But looking back at this data here, this value is higher than that upper fence that we had of 10,567.5. This one right here is, I mean, it's close. It's close to it, but it's still under it. It's still underneath of that, inside that fence, so that's fine. So we're still good. But this one is an outlier. Okay, I'm gonna bounce back to that screen I was on. Oops, okay. So this is an outlier. So this value would be unusual. It fall outside what we would expect to find. So we're gonna have to take, we'll be taking that into consideration when we make our box plot. But questions on finding outliers using the interquartile range? All right, moving on then. So we have something called a 5-number summary. So the 5-number summary, it basically just takes the important pieces out of our data set. So we don't have to lug around all of the data values all the time. So we just take those important numbers. So you don't have to label them. If I asked you for a 5-number summary, you just give me all 5 of these numbers in this order: minimum, Q1, median, Q3, and maximum. You just give me all 5 of those numbers in that order, and you know it's a 5-number summary. And then those are all the important values that we need to use when calculating things. Like if I was looking for an outlier, I have Q1 and Q3, I can find my IQR and I can find my fences. If I need to know where the middle of the data is, I have that. If I need to know, do I have an outlier? My maximum, if that's higher than my upper fence, I know I have at least one outlier. If this minimum is lower than the lower fence, I know I have at least one outlier. So all this is the important pieces of our data. And then all we have to consider is these 5 numbers and not look at the data as a whole. So we're going to do an example. So let's find the 5-number summary of the speed data. And of course, I don't remember what our values were. I'm going to go on my other computer real quick and I have the PowerPoint up so I can look at it. Okay. So the speed data, my lowest value, my minimum is 20 of my speed data. My Q1 was 28. My mean was 32.5. My Q3 is 38 and my maximum is 40. So if I ask for a 5-number summary, you just write it like that. And it's just known if you have the 5 numbers written in that order, it is your 5-number. I mean, we know what they are. I could tell you, oh yeah, there's the 5-number summary. That's Q1. So you don't have to, uh-oh, what did I do? What did I do? Okay. So you don't have to label them. So let's talk about the 5-number summary of the collision data. Our smallest value of the collision data. I don't know. How come I don't have that up on my screen? Let's go to that. It was $180. So the smallest value was 180. Then I have $735 was my Q1. My median is 1805. Q3 4668. And then my maximum value is 21,147. There's my 5-number summary. You don't have to do anything else. That's it. Just find those 5 values and write them out in that order, and bam, you are good.
Melissa, I have a quick question. So I ran into this problem yesterday when I was trying to type information into my L1 graph.
Uh-huh.
So
Oh, what happened?
give me
Okay, so sorry, go ahead.
okay, so I had too many numbers in my L1 graph, and then when I went to the data that I was putting in was like less numbers. But I remember you said do not hit delete. So how do I get rid of the number?
You highlight the top, you highlight the L1. So go all the way to the top so that L1 up at the top turns black. To highlight it, then hit clear, enter.
Thank you.
Don't hit delete, hit clear. Clear, enter will delete all of them. But the problem if you hit delete is you lose the entire column, and then your first column will be L2. So that's what the delete does. But if you hit clear, enter, it just clears all the data out of there.
Thank you. I didn't hit delete. I figured it out by hand so I could ask you about it today. Thank you.
Perfect. No problem. It's a good question. Anyone else before we move on? All right. Y'all are hanging in there so great. Good job.
I have a question.
Yes.
Can we look at the one of those data sets, either the insurance? Can we look at the money, the
Yeah.
box with all the?
Yeah, hold on, let me get back there. Do.
And my question is, because the numbers fall right in the middle, I guess because we have an even number,
Mhm.
then like Q1 is 735. So if we had an even number and Q1 fell in the middle,
Uh-huh.
we just add up
You would do the same thing, like if it was right here, you
Yeah.
would do 618 plus 735 divided by
divided
2.
by 2.
Yeah, you treat it exactly like the median.
Okay.
Yeah, good question. Good
Thank
job.
you.
Mhm. All right, I'm gonna go all the way back. I mean, I know there's a quicker way, but I'm just determined not to make my PowerPoint go away and come back. All right, we're gonna talk about a box plot and what that looks like. You've seen box plots. You may have seen them. I know that years ago, it used to be a standard that they taught in 8th grade. They used to teach box plots. It's kind of gone by way of the dodo. They don't really teach it much anymore, but some people still do. So you've seen them. That doesn't mean you know how to do them, but so we're going to go through that. So first thing you want to do, this is not actually the necessary order we do things, but this is the order that they tell us to do it. So first thing, find your lower and upper fences using your 1.5 IQR rule. So you figure out where outliers are going to be. Next thing, so this is how we do those. The next thing you're going to do is you're going to draw a number line. So important here, the number line underneath your box plot is just a standard number line. We are not like specifically labeling your 5-number summary or any other things. It is just a very standard number line, 0 through whatever number you need it. It is a standard number line. So that just wanted to let you know, it is just a normal number line underneath your box plot. And then you're going to label the fences. You're going to label your upper and lower fences. I'll show you how to do that. Okay. And I know this is going to make a lot more sense once we do one. And once you see it done, I know that instructions like this don't make as much sense until after you've seen one done. because that's the way my brain works. Not that I'm completely normal, but just majoring in math made me not normal. Finally, you're going to draw a line from, does it have you labeling the, okay, no. Oh, wait, I didn't do this one. So we need to, you put a vertical line at Q1, median, and Q3. These are going to be a box. You're going to enclose them in a box. You'll see what it looks like in a minute. Then we label our fences. Sorry about that. Important thing with the whiskers. The line for your whisker of your box and whisker plot goes from Q1 to the smallest data value that is inside your fence. The whisker on the top of your box goes from Q3 to the last data value inside your fence. Don't worry, you're going to see this a couple of times and it will make sense, I hope. And then that's your box and whisker plot, and it's nice and pretty. You might want to put a title on it. You can make it colorful. You don't have to make it colorful. Just saying you can. But any value that is outside of your fences, any value that is an outlier, you need to put an asterisk there. You need to label it with an asterisk. And that if you do that, then I will recognize that that's an outlier. It's showing like, hey, look at me. I'm not in the fence. I'm the cow that skipped out of the fence and I'm out lying in the field. Right. I'm a weirdo. It's just what I do. So let's take a look at what a box plot looks like. I'm going to show you a nice, pretty computer generated one. And then we're going to draw one together. So we're going to use credit card plans and their interest rates. We're using 10 credit card issuers. The data doesn't matter. You're not going to do it. It's going to do it itself. Here is the box plot. So I have an outlier over here. It looks like it's about 6.5%. There's an outlier outside of my fence. These right here, I'll do a different color. I don't like this. These right here are the fences. It looks kind of like a hard bracket. These are the fences. You just label them on the number line. So what this goes to, this whisker here, goes to the last data value that is inside the fence. So I know that the fence is way down there and I have the outlier there, but this is an actual data value right there. There are no data values from here in here. There are no other data values there. That's really ugly. Okay. And then our highest data value inside the fence just goes to right there. Do not just draw your lines all the way to the fences unless the fence is a data value. Also, there's no need to label your quartiles. I'm going to label them for you just so you can see where they are. This is Q1, this is the median, and this is Q3. Do not label them on your box plot. I just want to show you where they are. Any questions before we do one together? All right. We're going to do one with the highway loss data, the insurance stuff. We're going to do one of those together. So sometimes it's hard to know exactly how long to make your number line. I've made this one so many times that I kind of know how to break up my number line. So I'm going to go start here and go all the way down here. And I'm going to show you some tricks of the trade. So I'm going to start with 0 right here. And then I'm going to go up 500, but I'm only going to label the thousands. So this is 1,000, 2,000, 3,000, 4,000, 5,000, 6,000. Okay, I'm going to stop at 11,000 really quick here. And I'm going to show you guys some magic. So sometimes you have a big spot where there are no numbers. So I don't have any data values between 10,036 and 21,147. So I'm going to do something called putting a break in the graph. You basically put like a squiggly mark like this, and this is just me breaking the graph. So I can now start at 21,000, 22,000. So I broke my graph and then basically I cut out like a 10,000 chunk, $10,000 chunk. I cut that out so that I don't have to draw the line all the way out, because that would be a lot. So if you have like a big empty spot that is kind of meaningless, you can break your graph and just make sure that you make a clear like squiggly or like, you know, cutting part on there, and you can break your graph. So that's what I did. It's almost cheating, but it is, as I said, it's kind of a trick of the trade. You learn it after a while. And so there you go. All right. So the next thing I'm going to do is I'm going to put vertical lines at my median, Q1 and Q3. So my median is 1805. So 1805 is probably about here. Okay. My Q1 is 735. So Q1 is about right here-ish. It's just, we're just kind of guessing. And then my Q3 is at 4668. So Q3 is about here. And then enclose those in a box. It's okay if you make it taller than mine. It can be more boxy, whatever you want to do. I'm going to change colors just because I like to do that. And I'm going to go with, I need to label my fences. I'm going to do the upper fence first because it's easier. My upper fence was 10,567. So my upper fence is approximately right here. Now my lower fence is way off my graph. It's 10,000, it's negative 5,164. Usually if I end up with some really wacky negative number, I just put it off the edge of my graph and just call it good and just leave it way off there. You can label the number if you want. Nobody's going to get mad at you either way. You can label it or whatever, but I mean, it's a completely ridiculous thing because negative numbers don't make any difference in our data set. So however you want to indicate those is fine. But I just stick it off the edge of my graph. All right, let's go with whiskers. So my whiskers go to the last data values inside the fences. So my lowest data value is 180, and that's inside my fence. So it's, let me see, 500's there. Say it's about here. Okay. It's just a guess, somewhere between 0 and 500. It's really hard to say. My highest data value inside my fence is 10,034, I think, or is that 36? I can't read my own writing. It might be a 6. It's either a 6 or a 4. It doesn't really matter. So it basically goes up to just 10,000. So I need to go all the way up here. Yeah, that's about right. Okay. So it's the last data value inside the fence. Pretend that line is perfectly straight. Finally, the piece de la resistance, the outlier. My outlier is at 21,147. So I'm going to put the asterisk right there. And bam, we are done. It's probably, my asterisk probably could have been a little bit more to the right, but we're going to pretend it's in the perfectly correct spot.
So that rectangular that you have, you call it the first quarter, the median, and then the third quarter?
Well, so yeah, so this, you don't need to label these. In fact, I don't do it. This is Q1, this is median, and this is Q3. So when you draw yours for the test, don't label them, but that's what they represent. That's Q1, the median, I'll put median, MED, and Q3. Those are the spots in our boxes.
Good. And then that little green looking star at the end outside the upper fence, what's that called again?
This is my outlier.
Thank you, sorry.
You're welcome. No, you're good. I like label. I mean, for your notes, labels are good. This is your upper fence. And then this is your lower fence.
And those green lines are just data values, right?
This is a whisker.
The whisker. Okay.
These are whiskers. But yeah, those are just, they represent where the data values are. And don't draw the whisker or all the way to the fence. Draw it to the last data value inside the fence.
Okay, thank you.
Uh-huh. Any other questions? Those were really good. Any other ones? I always get really excited that when I get to do I love doing the box plot for this. I don't know why, it's just kind of fun. All right, any other questions about box plots? Now Excel can do box plots for you, but they're really ugly. They're vertically, so their box plots look like this, and then they make them really squatty. It'd be like this. They're really ugly. I just don't like them, but I mean, they work, kind of. But that's what a box plot looks like in Excel, and I just don't like it. Okay. So I have one more slide, and then we'll do the lab. So the last, I just kind of want to show you. So our data here is skewed right, because we have a super long whisker over here on the right, and our box is leaning towards the left. So our data here is skewed right, and I just did some weird stuff there. So you can take a look. So the box plot on the left looks kind of like the one we just did. It is skewed right. A symmetric one, your whiskers are going to be pretty much the same length, and your median usually is like smack dab in the middle or really close to the middle of your box. And on a skewed left one, the left whiskers longer, and you notice how the median is like to the right of my box, inside my box. So this just kind of shows you the shape of the distributions and how you can tell with the box and whisker plot.
How are we going to draw a box plot on the test?
So you'll draw it in, you show your work on a separate sheet of paper while you're taking the test. And then at the very end, it prompts you to take a picture of your work, and you hold it up to the screen and it'll take a picture of it. If you don't think it's clear enough, you can also take a picture and just send it to me as well, if you
Oh,
don't think it's clear enough. But
Huh.
most of them I can read pretty well.
okay.
Yeah.
Okay.
That was a very good question. Nobody's ever asked me that before. That was
Huh.
great. Awesome. Okay. So that is it for the notes for 3.4 and 3.5, but I'm going to do the lab next. It won't take very long at all, but I am going to show you both computers, both Excels, so you can see what the how to do find the tools. Now I want you to know, so I'm gonna move over to my Excel real quick here. So this is lab 2. The tools that I'm going to show you will not work with the web version of Excel. It needs to be the downloaded version. If you want to do it on RCC campus, they've got Excel there, and you're more than welcome to use their Excel. Or if you go to, unfortunately, it kicked me off of our Blackboard. Let me see if I can get back there real quick. I don't know why it kicked me out of the internet. It just was mad at me or something. But how dare you use calculators online? I don't know, sometimes it's just weird. Okay, it's thinking about it. But just at the bottom of the assignments and lessons page, at the bottom of that page, you can see there's the Microsoft Office that you get free from RCC, and you can use that as long as you're a student. There we go. Maybe. My courses haven't ramped up. Yes, they have. Okay. It's like, what are you talking about? So assignments and lessons page. If you scroll all the way to the bottom, we've got this free Microsoft Office, and it is the entire Office suite. So if you click on this attached files link or to the either any of these links, you can download the free Microsoft Office products. Or you can just use the computer labs at the school if you want to. They all have Excel there. Okay. So this is my Excel. I have, let's see here. I'm using my continuous data from Lab 1. Please use the continuous data from Lab 1. If your data was actually continuous, use that data because there's no need to spend extra time. And you are going to need to collect data for Lab 3. Okay, so the first thing that we need to do is we need to have a descriptive statistics tool. And I'm going to show you two different ways to get that depending on what your Excel looks like. I'm sure there's more than one way. So I am on my MacBook, and some of us on our MacBook, it looks different than other people. So you're probably going to start off with this would be your normal toolbar, just your normal thing here. You click on data up at the top right here. And so all the way on the right, it says analysis tools. There's nothing underneath of it. I need to have a different analysis tool added on here. So I'm going to click on tools. And then I want the analysis tool pack. I don't need anything else. Just click on the analysis tool pack. Click OK, maybe. So, and then data analysis shows up underneath of it. So that's how to get this tool on this particular computer. Now I'm going to stop sharing and I'm going to share with my other computer. Give me a second. I want Excel. Okay, maybe. Okay, so I'm on a different type of Excel now. Why isn't it full screen? I don't know. It's very strange. Okay, so on this version of Excel, this is the one most people will have. I'm going to click on File. Hold on. Click on File and go all the way down to Options at the bottom. So File and then Options. And then I want add-ins. Add-ins is down here near the bottom. So you click on add-ins. Once again, near the bottom, it says Manage Excel Add-ins. So click on add-ins, then Manage Excel Add-ins, and then click Go. Gives you a pop-up. I want the top two, the Analysis Tool Pack and the Analysis Tool Pack VBA. Those are the two things that I want clicked. And then I'm going to click OK. And that'll give me what I need. Notice over here on the right now, it has data analysis. That's what I want. So when I'm in the data tab, I want it to say data analysis over here because that's the tool that I'm going to use. I'm going to get out of this because I don't like using this computer for that because it's way over there. All right, I'm going to share my screen again. And go share my whole screen. Go back to Excel. All right. So now that we have data analysis on both of my computers, I move this thing. I have a weird toolbar that's really annoying. Okay, so now that we have the data analysis tool, I am going to click on the data analysis, and it's going to pop up this menu right here. What I'm looking for is, where is it? Descriptive statistics. So in the data analysis tool, I want descriptive statistics because this is going to basically give me like the stuff that my one variable statistics gives me on my calculator. It's the same type of thing. It actually gives a little more than that, but that's the most important things that I'm looking for. So click OK. And it's going to give you this window here. I have weird things happening. All right. So the input range is going to be all of my data. So click on the input range box and you're going to highlight all of your data. Mine is really long. Yours is probably not as long as mine, but I'm a wackadoo. So mine like goes to 140. So highlight that. Now, if you highlighted not enough or whatever, you can change this number. It doesn't matter if you can type things in here and change this if you want. And what I need right here is I want summary statistics. So once you have your input range, go down to the check boxes and check on summary statistics. Oh, what I didn't do. My output range right here. What I want for output, uh-oh. I want it to land in this box. My output range. I want it to land in that box. So click on output range and check in this box. I want it to land in here. Otherwise, it's going to open up a new window and it's going to throw it somewhere funny. Once again, click on the output range box right there. Check, just click in the box and then highlight where you want it to land. I'm going to click OK. Take a look. I'm going to make these bigger so you can see them. And so what I've got here, this gave me the mean. Standard error is not what you're looking for, but we have a standard deviation right there. Remember, variance is just standard deviation squared. It doesn't even matter. We are not going to deal with kurtosis and skewness right now. We're going to leave those alone. But look, I have median, I have mode. It gives me the maximum and the minimum. It gives me adding them all together. It tells me how many there are. It gives me the range, which is the highest minus the lowest. So it gives us a lot of good information. So the point of this lab is for you to use Excel tools for everything you can possibly use Excel tools for. So I don't want you to type numbers in boxes. I want you to use the Excel tools. So take a look here. Quick, hold on. So take a look. I'm going to go into the mean box. And whenever you type equals, it's telling Excel, I'm going to give you a command. I want you to do some math here, or I want you to insert something here. So whenever you put an equal sign in, then it's like, okay, it's going to wait for a command. So watch, I'm going to put equals, and then I want it to equal this box over here. The box that's my mean. So I'm going to click on that box. So I want it to equal what's in this P6 spot right here. Hit enter, and it's just going to input that number for me. So on standard deviation, I'm going to hit equals, and then I'm going to click on the box over here that is standard deviation and hit enter. We're going to talk about number 2 in a minute because I want to go do the rest of it first, and then we'll come back to number 2. So now I want the median. Once again, click on the box, put in equals, and then click on the box over here that says median and hit return. Same thing with mode, click equals, click on mode right here and hit return. So I used Excel tools to put those things in there. Yes, I know you could just type them in, but the point is to learn how to use Excel. So number 4, what I want you to do with this box, I want you to talk about your mean and your median. And if they are close together, you're going to say it's symmetric. If the mean is greater than the median, tell me what that means. If the median is greater than the mean, tell me what that means. So basically what I would say for mine is I would say that my mean and median are very close to the same number. Therefore, my data value, my data is roughly symmetric. So if yours is skewed, you're going to talk about it skewed because my median is greater than my mean, or my mean is greater than my median. So you need to talk about why it's skewed based on the relationship between your mean and your median. If that makes any sense. What's going on here? Okay. All right. Next, our 5-number summary. 5-number summary is so fun. All right, I'm going to click equals and then get my minimum, which is over here. Quartiles. This is the fun part. So watch this. Equals. Start typing in quartile. QUA. So notice right here, I have quartile, including and excluding. It doesn't really matter which one you choose because it doesn't matter. Just doesn't matter. So, and I want, it even tells you what to do. Array. So this would be all of my data values. So hold on. Array. Highlight my data values. Okay, highlight my data values. I really wish I would have used a smaller data set someday. Okay, so I put array, all my data values, comma, I want quartile 1. So I'm going to put 1. And it kind of looks, notice how it gives you the options. So it kind of tells you what to do. Then I'm going to hit enter. It gave me my quartile 1. This Q2, of course, is just my median. That's just my median, so equals that. Once again, quartile 3 equals quartile. My array is all of these. Okay, come on. Come on, come on. Okay, all of those. And then okay, all of those, comma, quartile 3. Close my parentheses, hit enter. The high is my maximum, so I'm going to hit equals maximum, enter. All right, so it put all of those values in there, it populated them. So for the IQR, I want to subtract Q1 from Q3. So watch how this is going to work. I'm going to say equals, click on Q3, and hit minus. Now click on Q1, hit enter. It's going to subtract those for you. I'm going to show you that again. So if you look here up at the top of my screen, you can see the math that I typed in there, equals F35 minus F33, and just hit enter and it'll do that math for you. Okay, finally, Z-scores. I am actually not going to require you to use Excel to calculate your Z-scores, but if you want to, go for it. So what it's asking is, do you have any unusual data? So I want you to, and we want to use Z-scores. So we're using the mean and the standard deviation. You are not using quartiles. So you can, if you want, you could calculate your critical Z-scores. You could determine what 2 standard deviations above the mean is and what 2 standard deviations below the mean is, and then determine if you have any values lower than those or higher than those, or you can calculate your Z-score. So I could take this right here. I'm going to show you how I can math it using Excel. As I said, you don't have to. So I would put like Z equals, and I'm going to go over here and say equals, let's say parentheses, this right here, minus this right here, close my parentheses, divided by this right here. This is going to give me the Z-score of my lowest value, negative 2.408. That is an outlier. And I'm going to do the Z-score of my highest value. So I have highest value is 9.3. So Z-score of, I didn't do my equals. Equals, once more, scroll down. 9.3 minus 7 point whatever divided by that right there. And those are both outliers. So I have upper and lower outliers. And then you're going to type words in here. I can say, this value represents my lowest Z-score. This is my highest. So therefore I have outliers. Or calculate your upper and lower boundaries. So do 2 standard deviations above the mean and 2 below, and say, I don't have any values above that or below that. Whatever you do, you need to reference your values, reference the Z-scores, and tell me whether or not you have outliers. That's it. Then you're done. This should not take more than 5 to 10 minutes max, especially since you already have your data. Okay, so now questions while it's being recorded. Any questions while it's recorded?
Question.
Yes.
You can see the work. You can see if we entered a number like in the mean by hand, or if we use the shortcut, right? That's
Yes.
okay. So, good. Just asking. and then, so will we be expected to know how to do this on the test?
No, the test is not, there's no Excel on the test.
There's no Excel on the test. Okay.
No Excel on the test.
Okay.
You will need to use Excel for your final project, but that's weeks away. So you're good.
Okay. And that's in our own time anyway. We don't
Yeah.
need to present that in real time or anything.
No,
Okay.
that'll be kind of like the work behind your project, but I'm not going to be requiring you to do Excel on the tests.
Okay.
Excel is so incredibly useful to know. I use it for so many different things in my life. It is super, super useful. So even the little bit of knowledge I give you on Excel, hopefully it makes you guys hungry for more because it's so useful. But
Cool. Okay, but no Excel on any of the tests.
correct. No
Excellent.
Excel on any of the tests.
Thank you.
You're welcome. Anyone else? Okay, I'm gonna stop the recording.